Thank you. Well, we're kind of keeping with the tier supplier thing because we have 3 tier suppliers at various levels to come and speak with us now. So we're looking at material matters, so body forming, process transformation. OEM suppliers adapting to a range of material choices now, combinations and approaches in production, often trying to simplify the process in terms of structures, reducing weight and therefore emissions. Electrification and sustainability is leading to changes in body and white. And we're seeing that with the introduction of some innovative high-strength steels, aluminium, alloys. And also, if we take a look at the interior and at the smaller components, the plastics and metals used across interior trims and assembly, and even around the powertrain area. So this session, we're going to learn a bit more from the suppliers, how the manufacturers are adapting with forming and injection processes, some new technologies, materials, and a bit about trends and directions, and some of the challenges and solutions that the tier suppliers are coming up with. So I'd like to first introduce first guest is Jonas Adolfsson, who's Business Development and Project Mobility Docol for SSAB. Thank you, Jonas.
Thank you.
Thank you. Continuing with the steel theme, Jesse Paegle, who is Automotive Steel Solutions Director at ArcelorMittal. And Jesse's worked with leading companies like Gestamp, Renault and JWE and battery pack and chassis components. So come on up, Jesse. Ooh. Thank you. And final guest is Michel, who is Group Technical Engineering Director at Teknia. Thank you. Thank you. So materials, it has been one of those topics that we've covered quite a lot, and there's been quite a lot of ebb and flow. There have been certain trends in when a lot of composites we're looking at are being used, with shift between aluminium, steel, plastics, and now we're dealing with sustainability, formability, lightweighting again is now back at the top of the agenda. So, I mean, at the minute now, looking at the automotive industry, so the tier suppliers, the structures and the OEMs, they're having to balance, when they're making their materials choices, sustainability, cost, lightweight in some instances, and certainly production as well. I mean, what are your views on where they're prioritising? I'll come to you first, Jonas, where they're prioritising some of these balancing and some of these decisions.
Yeah, if you start looking on a life cycle assessment, and just one example of Volvo cars with a combustion engine, the tailpipe emission stands for 73% of the total emissions over a life cycle. And going to electrification, and if we take the example with green electricity, you come down to 1% of the emissions. And then the material stands for a bigger part, or a huge part of it. In example, the emissions from the battery, 26%, from aluminium, 26%, steel, 70%. And to keep up with the sustainability transformation they need to do, and also to become climate neutral at a certain point, they need to put focus on what kind of material have to use it in the best way, and also to start to minimize the emissions from these materials.
Because, sorry, cost has been an issue for them, hasn't it, around this at the end of the day? They're having to sort of balance that out with not only having the materials that are available to them, because there are, you know, we mentioned there are innovative steels and alloys, but also balancing that with the manufacturability of it, so that it causes the least disruption and doesn't overcomplicate what is already a complicated production process for them. So again, the processes they have now, they want to retain in terms of joining and forming. I mean, and that comes down to sort of your comments there, down to the decarbonising of that material supply chain. I mean, Jesse, can you sort of offer some insights into that from ArcelorMittal's point of view?
Yeah, this is an important point, of course. We speak up a lot about it. of course. We have two ways, in fact, inside ArcelorMittal to treat this challenge. One of them is, of course, the green steel, production of material, because the CO2 footprint is mainly linked to the production of the material. But there is a second way that we can look at is the usage of material in general. So reducing the amount of material you use to have a final part, you are saving CO2 somehow. And this is a point that we can see in our booth over there, where we have a nesting optimization of the blank to reduce the amount of material that I need to produce each part. So there's two ways in our vision. One is linked to the material itself, of course, and the green steel. And the second one is using less material. The less material I use, the greener I will be. It's something that I used to say from time to time.
Yeah, I mean, that's an interesting one. That you're basically wanting to sell them less materials at the end of the day. And I know, I mean, from a production side, from both SSAB and Arcelor, production operations to decarbonise that has been a big project for both of you, and not just because there is a requirement, but obviously from a car maker point of view, you both supply heavily into the automotive industry. There's been obviously a demand and a requirement from them from their sort of sustainability programs for you to meet certain targets in that respect. So, Jonas, that's been a key factor in some of the developments that you've come across with in terms of the production operation. Yeah,
I mean, we focus a lot on it, and just look on the transformation we need to do, and also to get more circular. It's easy to start think that scrap-based steel or aluminium or other material is the solution. But the challenge is that it's not enough of scrap on the market. So if you put too high requirements on a certain level of scrap, you force someone else to use virgin material. So you don't help the earth from a total point of view. And that's why we were focusing a lot of we need to find new ways of producing steel. Even if steel is the most sustainable material you can use today, we need still to decarbonize it. And we're looking into new methods and come up with direct reduction using green hydrogen as the solution. And that's an ongoing development, isn't it, at the moment? That's something you're working towards. And there's also been, I understand, a lot of upgrading around the actual foundries as well. So the steel plants as well are undergoing sort of transformations as well. Michel, if I can come to you, tier 2 supplier.
Yes.
So you're dealing with a multiple number. You're dealing with aluminium, steel,
yes,
plastics, and your diverse range of components for the vehicle.
Yes. When we talk about supply chain, let's say that we also talk about tiers 2, like Teknia. No? We are what we can say a proud manufacturer of metallic and plastic components, using, let's say, what we can call as traditional and mature technologies, like stamping, tube forming, aluminum high-pressure die casting, plastic injection molding, and bar turning. No? And let's say that we have improved those technologies for many years in Teknia. I am working in Teknia the last 30 years, and we have improved very much the processes. We have got in some way perfect products and processes at competitive prices with high quality. This is what most of our customers are demanding from us. No? And now you were talking about sustainability. It's true that we, as we are, let's say, a tier 2, we don't have so many opportunities to impact in the sustainability of the system, by making our own design or by taking decisions in regards to the materials. No? Not many. In some cases we can, but not in all of them. But what we can do for sure is using our knowledge, our experience in the processes, we can design the better processes to save material, especially because, you know, we have different technologies. For example, in stamping, the difference between gross weight and net weight can be tremendous. You can waste more than 50% of the material you are starting the process. So in those cases, as some speaker has commented before, we can nest parts to minimize the waste of material. Also we can use in plastic, for example, different technologies like Michel technology to inject some gas in the plastic melt in order to minimize the density of the material and to obtain lower usage of virgin material. We can say that in a very modest way, but we can't help very much by using, let's say, our expertise in both processes and products in order to minimize the weight of the materials, no? And the waste of materials.
Yeah. I mean, it's Scope 3 requirements now, and is that something that's starting to something you have to look at now and evaluate?
Yeah, we are a company that we are measuring, especially in regards to the Scope 1 and 2, we are measuring our emissions the last 10 years. We have got impressive results in those two scopes. It's true that in regards to the Scope 3, that is very important in you know, the production of the steel, the production of the plastic generates much more emissions than our own processes, no? It's in a proportion of 9 to 1, 9 coming from the materials and 1 coming from our processes, no? We, since 2 years ago, we started to measure our Scope 3, and we are trying to put aggressive targets in all the automotive chain. It's true that it's not easy for us to let's say, to have a lot of impact in that scope, because, I mean, we are a little bit in a sandwich, no, between impressive OEMs and tier ones, some of them here that are customers of us. In the other hand, we have also global and big material suppliers. And so, of course, we can try to help and collaborate in the chain to put targets, to measure and control those targets, and we will do our best.
Sorry, Jonas, you wanted to add something?
Just adding that, as you said, the Scope 3 for the producers will become very important, which is, in example, the steel itself. Now we have found solutions how to eliminate our Scope 1 and 2. So next step will be our Scope 3, the different alloys like manganese, silicon, and etc., that they become fossil-free and carbon neutral in the future. And what we also see is these alloys that we are using in the steel and also is used in the aluminium is a lot common with the battery materials that is used. So it's a work that can be done together, how to make these materials fossil-free in the future. And as said, in a life cycle assessment, the materials from the batteries from steel and aluminium is a big part.
Yeah.
And even if we start to have solutions now, we need to go further on in the decarbonization transformation.
And Jesse, Scope 3 for ArcelorMittal.
Yeah, it's exactly the same. We have in the same line of looking the process itself to have our green material. Beside the fact that we are also analyzing the scrap rate that we can use, sometimes it's not that easy for the steel grades that we need to apply in the body in white, for example, because it's a high-strain steel, and we are not allowed to put a huge amount of scrap in this material. So we have a complete planning until 2050, passing through Scope 1, 2, and 3, which we call it X-Carb program inside ArcelorMittal.
So, and at the back of that then, if there's more demand for, let's say, the scrap materials that you can access, then it just must drive the price of the scrap up by a certain amount as well. So that becomes an expensive part of the material mix.
I didn't catch.
Sorry, I was saying if the demand for scrap, there's a limited amount of scrap that you can utilise, then there's a demand for that. Then that must drive the price of that up as a contributing material.
I mean, you have to remember that the infrastructure for taking care of both steel and aluminium is really established already today. I mean, it's more than 90%, almost 95% here in Europe of all the steel applications that reach end of life is taken care of. I mean, you always have some parts ending up on a backyard or is going back to the original position as iron oxide is rusting. So, I mean, we will never reach 100%, but we need to have, I mean, continue building up the amount of scrap that can be recycled. And I think also with a proposal of future legal requirements here in Europe of life cycle assessment, the PEF method will support that, that we built up so we can become circular in the future. We are not there yet because we need to be sustainable from a social point of view also, and to make sure that steel and aluminium and other materials will be available for everyone.
Because that's another initiative, the circular economy, that we're starting to see with a few OEMs now. And so I think Renault are recycling some of their older car parts. I think they're changing one of their car plants over for that. Just looking at process, do new materials present manufacturing challenges? Because I know to some degree that you have to avoid that at all costs. But does this, in your looking ahead, looking where we are now, did you see any sort of, are they creating more process steps requirements, different tooling?
Yes and no, but if you look the total cost of the solution that we are applying today through our ArcelorMittal tailored blanks part, it's we can by even adding a laser weld to these big panels, and by reducing the amount of material that I need to use, and by increasing the integration of reinforcements for these panels, we can be competitive enough with this solution. And more than this, following something that was said in the morning, simplification. Because in fact, what we are facing today in the market is the challenge of dealing with different powertrains inside the body shop. It means that modularity and simplification are key to achieve. So I always like to link this, because by saying simplification and looking at the total cost, I can be competitive enough, even adding a laser weld to these parts. Okay. So it's a mix of benefits that we can bring to the OEM. And for me, modularity simplification is one of the most important, beside the fact that I am reducing the usage of material.
Yeah, I can just add, I mean, we're always trying to develop the properties of steel, but I think we have to work very closely together. You have the material, you have the production methods, and you have the functionality properties that you want to achieve with the application. And you should not see these as separate islands. You should see what is the properties of the steel that I want to use, and what kind of manufacturing methods I have, and the property of that, and what to achieve, and combine them. really utilize the properties of the steel in the right way, or the manufacturing methods, as you were with laser blanking or whatever, then you will optimize the design and improve it even more. So even with the steels today, there are possibilities with improvements.
What is really a challenge, just to add one point to this, is that for nowadays, it's more important than ever to look the final function of the part. Even for us, steel makers, we need to go deep in this analysis to demonstrate how we can add value to the OEM, to the final customer, to the tier one, etc., etc. So what we put in place today inside ArcelorMittal is a specific division dedicated to automotive applications. We are not talking only about steel grades or high strength material, but also about how I can add value in some of the applications that the OEMs are looking for in order to find this way to the simplification, I would say.
Michel, I mean, a tier two spot, you're dealing with multiple materials at the moment.
Yeah.
So you do, and processes, so you've got high pressure die casting, you're dealing with steel, aluminium, plastic, so you're doing injection molding for that as well. Am I right in saying that? Machine turning as well, we'll come on to that in a little bit. So I mean, in terms of process management, I mean, do you see, as cars are developed and the components you're being asked to produce, shapes, sizes, are you seeing more challenges in and around that, or is it at the minute where you are, is it more manageable?
Yes, it's an interesting question because, you know, for many years, a company like us, we have lived quite well, you know, providing to the automotive industry, let's say, different metallic and plastic components, most of the times by separate, using traditional processes and technologies, you know, and with limited possibilities of, let's say, of introducing innovation in the processes and materials, no? But now, as we are trying to focus our company more in the future, I mean, electrification, also new mobility, very important. Let's say that we are receiving many more opportunities to mix materials, to mix components, to provide solutions in regards to the function, to the functionality of the final part. And in those scenarios, what we see is that we need to leave our comfort, let's say, scenario from before, and to attack new scenarios where we need to, where we have the opportunity to innovate, for example, in joining techniques, because, you know, it's quite easy to weld aluminium to aluminium parts or metal to metal, but with different melting points. Now, to join plastic to aluminium is something very new in the market.
Yeah.
You go to the market and you don't find proper and competitive solutions, no? So we are having important challenges in regards to this, because we need to find new processes, combining different technologies and materials, and the last of all, and not least, remaining competitive.
Yeah.
Remaining competitive, that is not easy.
Yeah.
And now also the volumes in the electrification and new mobility are not helping. We are used to make large runs of productions. We have got perfect processes for that. But now with the new mobility, we are starting with much lower volumes, trying to make flexible production, what is a concept against the traditional technologies. I mean, yesterday in the BMW plant tour, we saw the pressing site, impressive, but very traditional in the concept. Not easy to, let's say, to make flexible pressing capacity, no? So yes, the challenges are impressive in the electrification of the car, also in the new mobility. I mean, we are not only betting for for automotive, but also betting for new mobility like e-bikes, e-motorcycles, and the uncertainty of the volumes is tremendous compared with the traditional business. So a lot of efforts in that direction. It's not an easy task.
Well, it's interesting, everyone's out of their comfort zone at the moment, aren't they?
Yeah.
I mean, that's the thing. It is interesting. You say the parts might look the same, but the material mix and requirements are different as they're being passed on to you.
Yeah.
It's really interesting the fact it's probably quite good for the company to innovate and move.
Interesting and challenging.
I'm sure, yeah. And the variability of volume is a big issue in tier supply as well, as you said there, when you're producing large volumes.
Yeah, it's a tremendous issue. For
yeah.
traditional technologies, it's a tremendous issue.
Yeah.
It's a tremendous topic.
Yeah.
It's not easy to, I mean, I have heard in many occasions about flexible production. No? When I go to the final assembly of my parts, of my components, you can design flexible cells to adapt to lower volumes in the beginning, higher volumes after. But when you talk about the first manufacturing production of your parts, either in plastic or in metal, those traditional technologies, I mean, it's not easy to remain being competitive with smaller volumes and especially with flexible volumes. No, it's a challenge for us, and we are studying and innovating in that way.
Yeah. I just want to come on to EV architectures, because I know both Jonas and Jesse, you've got active projects around that. And I kind of made a note that it was kind of like less materials but more cost for a full BEV, and when we're looking at them, and again, simplification of the process is kind of key, and they do look quite simple, but structurally they have a huge number of requirements around the battery enclosure especially. So could you just talk us through some of the challenges around those kind of architectures from a materials point of view?
It's the scenario that you are facing today, and what you said is quite nice, because in fact we are moving from our comfort zone. So we need to go, and more than ever, the OEMs are not just looking for a plastic or aluminium part or a steel grade part or a specific application. We need to assemble all this together. And this is, it was in the past, for example, the big challenge that we had was the hot stamping assembly process, but still. And nowadays we are dealing with aluminium, we are dealing with plastic, and of course with high strength material also as well. So the package of the solution that we need to arrive to the market today is not just coil with a specific steel grade. OEMs and tier ones are expecting for us solutions to save time, to speed the implementation of the new platforms in terms of EVs, for example, and the conception of the body in white of an EV. For me, it's completely different. If you look the ICE, we at the beginning, everybody were trying to use the same design for ICEs and to adapt to the battery. And the situation now is completely different. There we have more and more dedicated platforms, EV platforms inside the OEMs that we need to address differently, not only for the battery pack, but in the, how can I say, in the direction of cell-to-body or cell-to-chassis that Matthias this morning explained it a little bit. It's a new concept. So, and if you look each OEM, we realize that the design conception of EV is quite different. And in the future, who knows what we are going to see? I don't know even if the battery pack in the future will be necessary anymore, because we are going to integrate everything in the body in white. I don't know. I guess nobody knows really where we are going to be in 5 to 10 years. Yeah. So there is a milestone in 2026, but afterwards there is another one in 2030, and from there on, who knows? Who knows? And it's a mix of the concept, the design concept that we have today, and for example, micromobility in the future. It's growing a lot, and the design conception is completely different once again. So it's a challenge. It's a big challenge.
And it's an ongoing one as well, isn't it? Yeah. I mean, you mentioned, Jonas, you want to comment on this, but I mean, one of the things that is kind of, we're looking at a little bit is the battery enclosures is one thing, and it's moved away from quite bulky packs. You put the whole thing in. The way that the OEMs are planning to integrate it, and then the idea of basically having the floor of the car as the battery pack itself and then gluing the batteries into that. And there are challenges, I'm guessing, around production, I'm guessing around the structure and the material that you're going to use and the way that's going to form, because obviously things like rocker panels now have become very sophisticated when you look at the back of them. So, I mean, there are all those kind of challenges at the minute that are coming down the line, and we keep saying it, the goalposts keep moving along. So from a point of view of the kind of materials you're producing and where you're putting them, because it's key, the high-strength steels, where you're being required to utilise them and then form and join, lots of challenges. I mean, Jonas, do you want to comment on those kind of EV structures?
I just want to agree with you that it's very important to not look on the battery cage and the body and white and the chassis and so on as separate part. You really need to look them as an integrated functionality and see how you can integrate functionality into like one part. So, and I mean, for battery protection, we all know that battery cells are very sensitive, so we need to protect them. And also, in case something happens, we have to look on like fire resistance and so on, that we can handle all that kinds of things. At the same time, supporting cooling for fast charging and etc. So,
yeah, the structures are look simple. They're definitely not, though. It's really, really complicated. Just coming on to joining processes. I mean, you touched upon this a bit earlier. Michel, you mentioned there, like now you're being asked to join materials that you haven't never joined before. So you mentioned there plastic and aluminium. So this is part of that moving out of your comfort zone. So again, is from a tier spot, and again, the diversity of the products that you produce as well. Are you seeing you're having to bring in a lot more? Have you had to bring in new processes to accommodate some of this?
No. As I have said before, yes, it's a very challenging, let's say, new scenario. No, we are providing solutions. For example, in the battery area, we are trying to provide solutions mixing plastic and aluminium parts. In some cases, aluminium in different techniques like high pressure die casting or pressing, and we have to guarantee the final sealing of those different components with the adequate joining technique. As I said before, it's not been easy because in many cases the processes to join different materials are not, let's say, totally developed in the market. We are collaborating with plastic suppliers, even with some of our final customers, not only in the automotive industry, but also in other industry where they need batteries. And we are still in the phase of studying different alternatives, making a design of experiment to evaluate the alternatives, not only from feasibility point of view, from technical point of view, but also from competitiveness point of view. No? So it's been a new scenario. We are dedicating, let's say, new resources for that. As I said before, we are receiving many opportunities of co-designing those solutions together with our customers, something that in the past for a tier 2 like us was not so easy. For example, for many years we tried to make research and development with not so much success, because most of the big tier 1s has developed big, let's say, resources for that purpose. But now in the new scenario, as they have said before, we need to participate all together, having a look to the final function of the part, mixing technologies, mixing materials. All the chain has to collaborate in that direction. No way that we out of the chain we can have success by ourselves. We need absolutely good coordination and collaboration with raw material suppliers, with our customers, telling us about the final functionality of the part. No way to have success alone.
Yeah, and Jonas, did you want to comment on that?
No, yes, sir. I mean, in the sustainability transformation we're going, it's not only about recycling in the future. I think also a big trend will become reuse and remanufacturing. So meaning when the application reach end of life, you reuse some of the part to remanufacturing instead of producing new ones. And the interesting question, and I don't have an answer, is regarding the joining methods and so on. Do we need to have a transformation in joining methods to support reuse and remanufacturing in the future? So more questions to be raised.
It always comes up with more questions.
It's a good one. It's a good one.
We've just got time, probably one more sort of question to sort of put. I mean, one of the things we've seen a lot of with all companies now, for like supplying into the OEMs and the OEMs themselves, but is bringing in new competencies and buying new companies so you can be supplying or supporting your own business. A couple of examples that I know, Jonas, you might be able to tell me in a minute about what's happening with SSAB, but Michel, coming to you. High pressure die casting was something that it was a competence that you've brought in, and you acquired a company for rotor turning. Is that correct? Or Teknia did?
Yeah, let's say that we in Teknia are trying to focus more and more our group in the future of the automotive. No? In this case, we strongly believe in the electrification of the car. Regardless if we like it less or more, is the reality and is the future of this industry. And we are always having a look to the future, let's say, to the tendency of the market. Because of that, our M&A strategy has gone directly to acquire companies. In the last 3 years, we have bought different companies and always trying to find new products and new technologies that are an important actor in the electrification of the car. No? For example, 4 years ago, we had no aluminum high pressure die casting integrated in our group. But we thought that more and more that technology and that aluminum material was more intensively used in the market. No? So we decided to buy a group with companies in Spain, in Romania, and in Mexico, being specialists in high pressure die casting, in aluminum high pressure die casting. No? Also, in regards to the electrical motors, we have acquired last year a new company being a specialist in bar turning plus machining technology, and they are specialists in shafts in general. No? And we think that most of the electric motors need a rotor shaft to move. And we have integrated that company because of the knowledge and the experience in that area. No? So we are always, the M&A strategy in our group is, let's say, directly linked to the future of the industry. I mean, we have lived very well, no, in the past with our traditional technology and products, but to be honest, most of the profitability of our company is coming from our traditional products and customers. But if we want to see the future in an optimistic way, we need to see to new products, new technologies, and for the new mobility and for the electrification of the car. That is going to be key in our company. That is going to be key in the world. Yeah. If we want to survive, we need to go in that direction.
Yeah. I mean, interestingly, companies always need to acquire and grow and have new skills, but the pressure on Minute to do that is much more intense, probably, because of the speed that now you need to do that.
Because of that speed, that's why normally we have grown by acquisition of new companies, giving us new technologies, new products, new expertise. I mean, we have no time to, let's say, to create from zero those new products, those new technologies. No, we prefer to go to a good company. For example, last year we bought another company in Germany. In this case, specialized in, let's say, bar-turned products for the suspension of the cars, for the intelligent suspension of the cars. And we are always trying to check the market, and to wherever we see a good opportunity driving us in direction to the future, we go there, we buy the company, and that is why Teknia has grown so much in the last years, especially considering that 30 years ago we started being a company with 28 employees, selling less than 2 million euros. Now we are selling more than 300 million euros. We are close to 4,000 employees. I mean, we are modest compared with many of the companies present here, but we are going in the right direction.
Okay. Jesse, I know ArcelorMittal, am I right thinking you bought or acquired a recycling company to support? Is that correct?
It's a good question. I have my friend there, Frederic, that can help me with the answer. There is everything is in the plan. Through the decarbonization, let's put it this way. So it's part of the analysis that we are meaning today to understand which strategy we will follow. It's not easy. It's not easy because there is some technologies to process steel that we are evaluating. I guess SSAB is exactly the same. It's part of the strategy.
And Jonas, have you got some, SSAB got some partnerships that they've been working with in bringing in competencies? Or not necessarily?
Pretty sure we have. I don't know the details, but I mean, from a competence point of view, it's always important to develop it and make sure that you have enough competence, everything from material development to process development, but also to support the customers so that you're utilizing the steel in the best way. So to have competence in design, how to use the steel in the best way from a functional point of view, but also how to form it in the best way. So as I talk with the different islands to combine that, but also now in the future, how to produce in a sustainable way, and then from a total point of view, sustainable way. So using less amount of steel, not only from downgauge, but also from material utilization degree to improve that. Important areas. And
if I can add one point to this is more than ever, we discussed it a little bit about this before. We need to develop partnerships, good partnerships, and everything come together today. We cannot work in silos anymore. It's impossible.
Well, on that note, of collaboration and partnerships, which is great. I'm going to have to bring the session to an end, but Jonas, Jesse, Michel, thank you very much for your time and your insights. It's been a pleasure talking with you. Thank you.
Thank you very much.
Thank you.